last time I'm going to up the ante for this lesson. It's going to be all, I take off everything I've said about upping the ante after this when it comes to the next lesson, which is going to up the ante even more. All right, so over this one, power of a product property. This is our last triple P property, power of our product property. So we've had product to powers property, power to a power property, and now power of a product property. This property, again, builds on the last two that we were learning. We're going to be using the last two to sort of support this one as we continue on. So a product of a power, or a power of a product property tells us that a product, so a multiplication of two things raised to a power, so those two things raised to the same power, equals the product of each of those factors, so each one having their own power that it's being raised to. So essentially, looking at this example, we have a product of two power, or a product of two bases, 2 times x. That's essentially what we see when we have a coefficient in front of our variable. 2 times x is both of them are raised to the 4. They are both dealing with that 4 somehow. That means essentially we can rewrite this as 2 to the 4th power times x to the 4th power. This is a prime example of when I would actually want you to usually do the math in front of that variable. I'd want to see you say 2 to the 4th power is 2 times 2 is 16, okay? I'd want you to write 16 times x to the 4th as your final answer because we can do this math. If it was 2 to the 10th power, different story. But 2 to the 4th power, you can do that math. I suggest you simplify that. Usually when you're in situations with the power of a product property, I would want you to typically simplify the front coefficient if you have it. All that being said, the big idea that we're supposed to be taking away from this is if I have two or more coefficients, variables, whatever they may be, 2 or more factors being multiplied by the same product or by the same power, I can split every single factor up inside here and assign them their own exponent. So here's some examples. 4p, that's a funky parentheses, raised to the 3rd. 4p raised to the 3rd. If I were looking at this, if I were to expand it out, that's truly me saying 4p times 4p times 4p. It's whatever is in the parentheses multiplied by the number of times the exponent tells me to. So 4p times 4p times 4p, I would technically want to rewrite this so all the numbers are multiplying each other and all the variables are multiplying each other so I can truly see what is happening here. So I would use the commutative property to get the numbers together and get the variables together. So 4 times 4 times 4, I could rewrite that as 4 to the 3rd power, or I could do that math because 4 times 4 times 4 is a number that I can handle. That's 64. And p times p times p, or p to the 3rd. So I can rewrite this as 4 to the 3rd times p to the 3rd, or 64 p to the 3rd. So that is the epitome of what we are doing over and over and over with an example problem. But the shortcut that we can take, because we don't necessarily, after you've handled this a few times, we don't necessarily have to do this work every single time to prove ourselves. You can start to use this shortcut of essentially saying this 3 is going to attach itself to the 4 as an exponent. And this 3 is going to attach itself to the p as this exponent. The reason why we can do this is essentially the 4 has an exponent of 1. This p has an exponent of 1. And this 3 is going to say 3 times 1 is 3. 3 times 1 is 3. So we have 4 to the 3rd power times p to the 3rd power. 4 to the 3rd power I can simplify to 64 p to the 3rd power. Done. Okay, this is simplified. All right, now let's up the ante. Let's see another problem where it's going to get a little bit more complicated. It's going to get more complicated because we could potentially have exponents within our parentheses. Here we go. Let's look at just that. Negative 5t squared. There is a lot to pay attention to in this tiny little expression here. One is we have a negative number, and this negative is within this parentheses. So that means that negative is being affected by this squared. That means I'm going to say -5 times -5 if I were to expand it out. As well, this -5 doesn't show an exponent, but the t already has an exponent of 2. What's important is this -5, even though it doesn't show an exponent, it has one, and that exponent is invisible. There's only one exponent that can be invisible, and that's an exponent of 1. Okay, so what's important is that you aren't looking at this -5 and saying, oh, it has this, it's -5 squared already. That is not the case. This t has its own exponent. This -5 has its own exponent, but the only exponent that can be invisible is a 1. Okay, so I highly encourage you, whenever you look at a problem that is as complex as this one is, and you're going to have multiple of them, so you might as well just get in the habit now. Whenever you have a base with add an exponent of 1 every single time. Okay, so it's that same sort of idea when we have like that -x. I was telling you it has that invisible number 1 right in front of it. It's that same sort of concept. It's going to help you sort of have a placeholder for things, and it's going to help you not make any mistakes. So this -5 to the first times t squared is raised to the second power. Shortcut tells me that I can take this 2 and multiply it by this 1. And I can take this 2 and multiply this 2. Now, what's making me nervous about doing that right away is this -5 needs to be affected by that -2. So it's important that maybe you expand this out first so that way you can truly see what's happening. -5 times t squared times -5 times t squared. Okay, so I have taken everything in here and multiplied it by the number of times the exponent tells me to. So then if I were to rearrange this so that way I can truly deal with everything, everything's being multiplied here. So I can rearrange it so the numbers are together, -5 times -5, and then the variables are together. So I get t squared times t squared. And now I can simplify this. -5 times -5 is technically -5 squared. And if I were to write that, I'd write it like this, -5 squared, like that. So that way I know that that parentheses, that negative, is going to be affected by that 2 or by that squaring. Or I can actually do the math and I'll say -5 times -5 is 25. T squared times t squared, I have the same base. I can add the exponents. That tells me that I have t to the 4th. And that would be my final answer for this whole thing. So now let's prove it to ourselves here as well that we can actually get that same final answer. So this 2 is going to multiply this exponent up here as well as this exponent here. So you get -5. And again, I'm going to be very careful to make sure that -5 is affected, that negative is affected by this squaring. So I'm going to keep it in parentheses. So 1 times 2 is 2. And then t squared is going to be there. So I have -5 squared is 25. T squared, t raised to the second times 2 is t to the 4th. So 2 different ways to look at it. This is using the shortcut that we were just learning. This is expanding it out and really showing why it works. Okay, one more example, and then I will let you go to work on things, and you can now see why I really upped the ante. These things get complicated very, very quickly, and it's super important that we sort of embrace that. So we have x squared y to the 3rd power raised to the 4th power times x squared y to the 4th raised to the -4th power. So I'm going to do this problem because there's so many powers and it's going to get so complicated. I'm going to start out just using my new shortcut that I learned. My new shortcut is saying whatever is on the outside with this power, it's going to come in and multiply this power here, and it will multiply this power here within that parenthesis. It'll do the same thing over here with this -4. It's going to multiply this power and this power. So I'm going to use this shortcut right away. It's going to make my life easier. So x squared raised to the 4th power x2 times 4, that's what that's going to be, y raised to the third power times 4 times x squared raised to the negative fourth power, and then y to the fourth raised to the negative fourth power. I'm going to put parentheses or times signs in there so it's a little bit easier to see. And now I can do some simplification. I can do the math here. 2 times 4 is 8. So I get x to the 8th power times y. 3 times 4 is 12. Then x raised to the 2 times the negative 4. So x to the negative 8 times y raised to the 4 times negative 4, or y to the negative 16th power. So we're now going to go back to our very first product of powers property, which tells us if I have the same base, I can add the exponents. So I have the same base here for my x's. That means I can add my exponents. 8 plus a negative 8 is 0. 8 plus a negative 8 equals 0 for that x, plus, or times, times y to the 12th, y to the negative 16th. That means I can add my exponents, 12 plus a negative 16. So I get a negative 4 for my y's. So my final, actually it's not even my final answer, my semifinal answer, x to the 0 power times y to the negative 4th power. X to the 0 power is 1. Everything raised to the 0 power is 1. So I don't even have to pay attention to this because that's 1. So I really am only paying attention to this. I have y to the negative 4th. All of this has simplified down to y to the negative 4th. All of this, y to the negative 4th. Is that not frustrating? It's totally frustrating. But y to the negative 4th, I'm not simplified because I don't have a positive exponent. We know when it's a negative, that's essentially telling us that this base is in the numerator when it should be in the denominator, or it's in the denominator when it should be in the numerator. So I'm going to move this down to the denominator, so I'd rewrite it as 1 over y to the 4th. Now, I have a final answer. Exciting, exciting. All right, that was a really long video, and I sincerely apologize. However, you need to know about it. So, after you watch all of these videos, please make sure you do the must-do practice problem and then attempt the exit pass. Do not hesitate to email me if you have any questions or concerns. I'm here for you. I am happy to create whatever other little support videos you may need, okay? I've got you. I will talk to you all later. Bye.